I just want to introduce Sharon. You've already had a sneak peek of her, actually, and she told me to bugger off because she doesn't actually need any introduction. So here you go.
Thanks, Hamish. And I promise I didn't use the words bugger off. I may have said, please don't enter into my time because I have no time. Have you heard that great quote from Mark Twain? I would have written you a short letter, but I didn't have time. Doing something in a very constrained period of time means that you've got to pay attention and you have to be very, 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 very focused. You need to know exactly what's going on and you need to know that everything you do is delivering value. Okay? So things like very short time boxes are the type of thing that we really want to pay attention to. So whenever someone says, hey, can I give you an introduction? I'm like, sure, no worries, here's my CV. And sadly, because I'm old, it's really long. Really long. If you actually care, okay? Seriously, if you actually care, hello, I'm Sharon, tweet me at SM Robson. If you want to know who pays me, I work for Tats Group. My current job is the head of enterprise agility, so my job is to transform how technology is using the way it works. We're rolling out a mixture of agility techniques, lean, safe, less. Any other frameworks that you want to name that have trademarks after them? X-Scale, DAD, all of those, we're using those. We're building teams of high-performing teams. We're using the Toyota Carter. Thanks, Kirk, upstairs. That was outstanding. We are doing Kanban. We're applying the lean techniques. I model off hospitals and hotels and airlines, anything that has high-volume, high-quality transactions that we're looking for. That's what I do. And then in my spare time, I think about testing and I think about agility and I think about the pain that a career tester like myself has gone through, okay? So one of the things that I like to badge myself is an experimenter, all right? Very, very clearly aligning myself with someone who applies structured thinking to everything that I do because I have no time. I'm incredibly time constrained. I have so many things on my bucket list. Seriously, and I'm halfway there, so I'm getting a little bit, what am I going to do next? Still haven't even climbed Everest yet, haven't been to New York, haven't done all the important things in the world like shop on Fifth Avenue, all of those things, right? So you with me so far? All right, so that's me. Feel free to tweet. Feel free to be in touch. I want to talk to you about experiments because experiments are the new buzzword. Do you know that I say 10 years ago, it's actually 20 years ago, it was agility. Then about 10 years ago, we started to get lean coming in. And now we're starting to talk about innovation and experimentation. And I'm like, yeah, this is great. Because every one of us know that when people are saying those words, they're actually saying shortcut. So we're doing agile, which means we're not going to do any paperwork. Yeah? We're doing lean, which means we're going to cut out all of the stuff that bores me. We all know this, don't we? Now, for me, that breaks my heart because I actually believe in agility. I believe in lean and I believe 100% in value. And as someone whose whole career has been built on finding value, when we start to talk about experiments and people start to say things like, oh, we don't need process, we're experimenting. I'm like, oh, no. And then they say things like, we're innovating, so we're just going to make stuff up as we go. I think that somewhere in the world, little design fairies just died. So we've got to be gentle to the fairies, people. Okay, we've got to look after the design fairies and the experiment fairies. We've got to look after the butterflies. We've got to make sure we take care of them. So what do we got to do? We have to realise that experimentation is not new. Has anyone ever run an experiment? Seriously? Have you ever eaten anything? Have you ever walked down the street? Have you ever crossed a road? You've run experiments. You just don't know that you're doing it because we all do it on autopilot. So I want you to think about experimentation. It's an incredibly ancient technique that we have been using to survive forever. That's how we got here. Okay, so I want us to think about experimentation. It is very trendy, but it is not new. And what we need to do is truly understand what the word means. What the word means, and then we've got to put it into practice. Okay? So, here we go. Direct quote from Wikipedia, so it may or may not be appropriately correct. But anyway, here's the quote. An experiment is a scientific procedure. Love that. Absolutely love that. My first degree was a Bachelor of Science with a double major in geography, so it's really cool. That's what got me straight away. I'm like, I love science. This is brilliant. And it's a procedure that is designed to make a discovery. With me so far? Make a discovery, which means find something, test a hypothesis, which basically means learn something. And just for the record, who was on my team upstairs just then with Kirk? Yeah? We won. You weren't on my team. There's a ring in over here. Put a hand up. We won. Anyway, not that we're competition, but we learned a lot. And we use scientific experiments to prove something, okay? To demonstrate a known fact. And this is where we start to get into the repeatability of things. Now, if that's what an experiment is anyone else in the room saying, holy cow, or whatever word you want to have there, this sounds a lot like testing? Anyone notice that? And you all understand that testing is experimenting. Everyone got that? Please nod. Otherwise, I'm so in the wrong place. Testing, an investigation conducted to provide stakeholders with information about the quality of the product or service under test. Sounds good, doesn't it? Yeah? Now, when I start to think about what experimentation means, and I start to think about what testing means, and then I start to think about testing itself, I think there is so many analogies here. If I am looking to find something, I'm going to be looking at doing exploratory testing, aren't we? That's the whole point of exploring, is to find something. You with me so far? Now, exploring is one of the great misnomers that we have in testing. Do you ever have the guys in your team, I'm sure you don't do it, who sit in front of the keyboard and randomly thump the keys, hoping to find a defect? Do you have those? And then when someone comes along and says, how long is it going to take? They say things like, oh, we're exploring. Don't know. Do you have that? And then when someone else comes along and says, what are you looking for? They say, oh, we're exploring, we don't know. I think, well, the biggest problem I have with that is explorers always knew exactly where they were going. They always knew exactly what they were looking for. The only thing they didn't know was how they were going to get there. So they always started with the destination in mind. They always knew that they were heading for the source of the Nile or to the Antarctic or the Arctic. They always knew. And they always had all of the tools and techniques available for them to achieve their goal. They didn't make it up as they went. So when you're doing exploratory testing, to me, that is the absolute essence of structured experimentation. Because you have to know where do you think you're going to go, and you've got to think about the tools you're going to use to get there, because you have no idea the path you're going to take. The exploratory nature of testing is figuring out the path, not the destination. And then we start to look at the other types of testing, and one of them got up here is structured or scripted or automated. Now, to me, this is where the money is, because this is where we use the myriad of our tools and approaches to really learn something. This is where we get huge coverage. This is where we start to gain massive amount of knowledge, and we produce phenomenal amounts of data, which is just great, isn't it? But we must know what we're trying to learn. Otherwise, we just create an awful lot of white noise. So same thing with exploratory testing. When you are doing your scripted or your structured or your automated testing, you've got to know what you're testing for, what your destination is. So once again, we're back to this science approach here. And then the final one, my favourite, regression testing. Who loves regression testing? Oh, come on, you know you do. You know you do, because it's the only easy one we have. It's the easiest of all, because it's just proving what we used to know, isn't it? So it's not even like we've got to find something out. All we're going to do is say what used to work still works. Yeah? And everyone knows that I'm a hyper-radical and I say that you should do your regression testing first rather than last and all that sort of stuff, but that's a whole different conversation, so we won't go there today. But I want you to realise that by looking at the things that we do with our testing, we are actually clearly defining what an experiment is. And when we don't understand the difference between our test approaches, and when we don't start with our destination in mind, that's when we get really, really, really tangled. And that's when testing takes an awful long time. But that's okay, because we've got all of the time in the world, haven't we? No? Oh. See, when you start to do waterfall, first thing you realise, you've got no time. And then when you move on to agile and iterative development techniques, you think this is going to be great. And you do, you test all the way through in short, sharp, iterative time boxes. There's no magic time button that we can find. So we've got to make sure that every test we run, every experiment is pointed and valuable. Which means we've got to think about it, we've got to think about it carefully. So, luckily, approximately 2,763 years ago, thinkers invented the scientific method. My numbers may be a little bit off there, all right, because I just made that number up. Just saying. Because Ptolemy is so not happy with me because he was at least 4,000 years ago and he was an experimenter too. All right, so scientific method, very, very, very structured. Here's what we do. Pose a testable question. How cool is that? Now, remember me from this morning about the hard questions? I really want to insert on this slide, pose a hard testable question, so that you actually are finding something out that is valuable. Do some research. That's code for impact analysis. And that's where we start to do our risk analysis, our risk-based testing. We look at what changes were made. We look at the value. So once again, back to what Kirk was talking about upstairs. Where is your value in this activity? Is it about getting everything over the line, or is it about getting the most high-quality things over the line? Totally different way of working. So you've got to understand that. You then have to figure out what your hypothesis is, and that's really easy. Has anyone ever said, I think blah, blah, blah? Have you ever said that? You've done it? Well done. You've done it? Yeah. You've hypothesized. Yeah? Has anyone ever said, I wonder what would happen if? Yeah? You've hypothesized. Has anyone ever said, if I input data set A through this process, I expect Y to happen? Anyone ever said that? And you ready? You ready? Yeah. Given, when, then. See how I did that? That's BDD, by the way. Just saying, just saying. When we do that, we're hypothesizing. We're actually saying, I think this is what's going to happen. That's great, isn't it? And then the next step in scientific method is to say, and how will I find that out? How can I find it out? So that's when you've actually got to design your experiment. And that's why I want you to think about the different types of experiments and the different types of testing, because if you use the wrong type of experiment to find out your result, you will get absolutely no value. Your results are going to be meaningless. How many times have we said to people that we report to, oh yes, we've got 100% coverage of the changes that were made? Which was one. Yeah? It's data, isn't it? Means nothing. Yeah? So we've got to be looking for those things. We want to make sure we design our experiments to collect meaningful and valuable data, and then we've got to look at the data and say, what does this mean? That's the hard questions. What does it mean? What is it telling me? Because then I have to change something based on what I've learned. I may have to raise a defect. I may have to put something back into the production loop, or I may go to production. But I'm going to take an action based on what I've learned. So when you start to think about testing like that, as part of a scientific approach, a structured approach to gaining knowledge, you know that you're going to have to make sure you're gaining the right knowledge to make the right decisions. Then we publish it, and that's just reporting, so we don't need to worry about that, do we? It's the whole point of everything we do. It's like the explorer drawing the map. That's the whole point. So if we don't actually share, and you nailed it this morning, the conversation, what are we learning by doing our activities? If we're not sharing that, we might as well go home, yeah? So we've got to be thinking about this. So we don't say those things when we're setting up our testing, but when you start to think about testing as a whole, this is what we do. We state our question. We start to formulate the hypothesis. I think. So if I'm doing performance testing, I am going to say things like, I wonder how fast this new version of the code will work in production. Yeah? My hypothesis is it'll be faster than the existing version of the code. Yeah? That's why I made a new one. Okay, so that's that. Then I've got to figure out what's the variables. Is it the code? Is it the environment? What has changed? And Kirk was really good upstairs this afternoon saying things like, change one thing. Because the more things you change in every experiment, the more you're going to end up with defect masking. And you are going to not know what changed and what caused the result that you're seeing. So you've got to be thinking very carefully about that. You've got to choose your controls. You've got to think about what am I comparing it to. So our question was, will this version be faster compared to the existing version? What does that mean? I need to know how fast the existing version was. If I don't do that, I have no way of assessing my results. So I've got to really understand, how will I know that my outcome has been achieved? So I've got all these things I've got to think through. Then I've got to just do it, conduct the experiment. Then I've got to collect the data. I've got to make sure that I'm actually getting the meaningful data. Then I've got to analyse it. And then I've got to ask myself, do I know enough? So just running one test case probably won't do it. So I need to know how much is enough for me to prove my hypothesis and then be able to say, yes, I know enough to make the decision. And this is why testing just doesn't happen with turning up, sitting in front of your desk, thumping the keyboard. It's about thinking through the value of the information that I'm about to provide. Does this sound too preachy? Is it resonating? Is everyone sort of looking down and at the floor as if saying, oh man, she saw me? I used to do it too. And this is what I want us to do as a profession, as a group of people who are interested in this stuff, and I know you are because you're here. This is where I want to say to ourselves, a bit like Shirley said this morning, sharpen your saw. Really start to pay attention to what you are doing and how you can do it better. And just applying some really good structured thinking is the way to go. You've got to design it. And it's not hard, you've just got to ask yourselves the right questions. What am I trying to find? What am I trying to prove? What data sets do I need? What inputs do I need? What type of tools, techniques, and approaches do I need? Do I just use something because it's there, or do I use something because it's the right thing to use? Oh, sweet. I've got 6 minutes, all right? So someone go and tackle him and we'll be good. Does everyone know that's Mr. Whippy, don't you? Hamish is off. I also need to know, and this is something that is really, really important, and I want you to think through as a tester, as someone whose job it is to find something out, and as an experimenter, I need to know what the output will look like. I need to predict what I'm going to see, because I need to be able to know if I've seen it or not. I need to be able to say, yes, that's right. Not only do I need to be able to identify that the outcome has occurred, but I need to be able to identify how I am going to store the outcome. Because if I'm doing performance testing, I need to have a heck of a lot of metrics and tools available to capture those metrics, because they're transient. There's not everything that I can capture with screenshots. I need to make sure that I have the right way of assessing what I'm trying to find out. And then I've got to make sure that I can understand what the results tell me. And this is my comparison between expected and actual. And I've got to know what I'm using to compare. And I've got to set that up right from the beginning. Otherwise, I'm going to end up with a whole lot of white noise and stats that tell me nothing. I'll give you an example. 97% of all statistics are wrong. See how easy that is? And we live in the world of data, so we can make these things say anything we want. What do they usually want to say? Is it good to go? Sure is, if you want to go out of business. So my favourite, BDD, absolutely love it, and that's part of why I'm here, active in this community, because my goodness gracious me, this is Experimentation 101, laid out, that everyone can understand by simply following Dan North's examples of given, when, then, we are building experiments. But if you wrap the greater scientific method around that, you actually start to get really meaningful experiments. So you are providing true value to your organisation and saying, this is exactly what we now know. We've either found something, learned something, or proved something. Rather than the, I don't know, looks good to me. What am I looking for? What behaviour or defect am I trying to find? Given, when, then, wow, what does that mean? So now what do? We've all had those conversations in our head, haven't we? Please nod. Yes, yes. I'm a paid professional whose job it is to do this, so yes, this is how I think. Good, this is what we like to see. But this is the style of thinking that we need to have. But the next step, and this is where experimentation is key, we actually need to derive the meaning. Because sending through a whole bunch of data sets, waste of time. We actually need to tell people, what does it mean? The conversations from this morning, share the learnings, and then understand what it means to us. Make sure that we use what we've collected and then pivot, change, learn and adjust. And I don't mean just decide whether or not we're going to release this solution to live. I mean things like, how can we build it better, faster, stronger? How can we change the entire pipeline to make sure that we are actually delivering value earlier? And that's the whole point of an experiment, to look through the whole process. The most important thing of all is to draw conclusions. We really need to wrap everything up, make sure that all of our knowledge from all of the areas of our workplaces, all of our pipelines, not just testing, comes together and gives us that cohesive view of what we're trying to achieve, because that's our job. So we want to draw conclusions. We want to make sure that we've learned about the right things, and we want to make sure that we've answered the right questions. So, does anyone have any questions?
Yep. From testing perspective, one of the biggest challenges that we tend to have is the mindset that testers don't write code or don't read code. And that sort of acts as a barrier of being able to create better experiments. How would you go about advocating to start getting that skill set?
Okay, so, hello, I'm Sharon. I do not believe that testers need to be automators. I don't. I mean, we're lucky. We live in the modern age. We've got tools that do that for us. You can drop and drag, you can do keyword, you can do data-driven. There's so many tools out there. I do not believe that testers need to know how to cut code. They do need to know how to read it. You must know how to read code. You don't need to know how to write it, but you do need to know how to read it. It's the language of your job. Yeah? So, I think that the skill is not in cutting the code, it's not becoming developers, but it is about acknowledging that this is the domain that we work in, and if any tester on any of my teams does not have the ability to walk to a whiteboard and draw the architecture, either the physical, logical, application, infrastructure, architecture, we're in trouble because you don't even know what you're looking for. You don't know where your bugs are going to be, which means you're never going to be able to design your tests. We all know bugs live on the edges of things. Yeah, that's where they live because they like it there. They like to hang out in the wild. Yeah? Now, if you can't identify the edges in your architecture, you're not going to be able to find where the bugs live, which means you're not going to design the right experiments. It's going to be the cross the fingers and hope I find some approach. If you don't know where the edges in your code is, so if you can't identify where a method starts and finishes, if you can't figure out where a parameter is passed to or from, you can't spot the defects. Now, I'm not saying we have to write it, but we really do have to read it. That's our skill set. Does that answer your question? No, you don't like me anymore now. It's all right, I get that a lot.
So it's great to see that we need to think and experiment. I guess one of my questions would be, given that you said we're moving towards agile, lean, and experiments, and a lot of other people kind of see this as restricting time, how do you suggest we find time to elaborate these experiments or put it into our day-to-day tasks?
Okay, you're really not going to like me. Just saying. So can you do your evaluation now? And then I'll answer your question. Because I hypothesise you are not going to like the answer. Because the answer is, it's your job. You don't have to find time to do your job because it's your job. And my position is, if you are not already thinking like this and you are a tester, you must learn this. And you must. You are being paid to deliver this service. And because testing is just this amazing black magic that no one actually understands except for testers, we hide behind the screen. And we've got to be very, very careful that we're not actually setting ourselves backwards. One more? So, do you still like me? Ah, good.
Now, since I'm not a tester, as you know, I'm going to go a little bit wider here, and I'd be really interested to hear your view of the tester and the testing mindset in product development as a general. So not just in terms of developing software, but taking that mindset, taking that thinking and the designing of experiments into a product development world.
Brilliant.
Take your view.
So just so you know, Mickey and I have known each other for years, and I may have paid her a considerable sum to ask that question. I didn't. It's a really good question. So one of the reasons that I've moved very strongly into agility, and the reason that I focus so much on how do we provide high value in the solutions that we deliver, is because I got sick of being left at the end of the life cycle and just having to deliver under incredible pressure. So I'm actually working very hard to move testing as a way of thinking further and further and further and further up the life cycle. You said it this morning, you said about design, behaviour-driven design. So the things that I talk about when I'm transforming my organisation is I want testers or people who think about testing things in every stage of the life cycle. And I want people to say, I've got a great idea, and then someone to say, how will you know it's great? How will you know it's an idea? What are we going to use to measure that? How will we prove it? Now, when we're in Agile, it's great because there's formal names for that. First one is acceptance criteria. Yeah, love that one. The other one is value-based planning, which means we don't do what we want to do first. We do what's the most valuable thing first. And we pay attention to those things. And the discipline is not necessarily in the body of a tester. The discipline is in the team recognizing that we need to know those things. I mean, software, product development, not even software, product development is the biggest experiment of them all. It's, I've got a really good idea, I'm going to cross my fingers and hope someone buys it. Yeah? And how many times do things go to live that people are like, don't care about? And then weird things take off. We need to make sure that we are thinking about these experiments all the way through, particularly if you work in a commercial environment, because you're playing with money, you're playing with shareholders' money. And very much if you're working in the government environment, because you're paying with mine. Yeah? And can you imagine a worse stakeholder than me? Because I'm going to be there saying, how do you know that's right? How do you know that's valuable? We've got to build it in all the way through the life cycle. We've got to have everyone looking for this and everyone paying attention. We've got to have those experiments perfectly constructed right from the beginning. Does that help? Any others? Time to go. All right, so wind up, got the wind up. Thank you very much. Hope it was valuable.